Hi everyone. So for today's session, we're going to be doing introduction to differential equations. So we're going to be focusing on linear, exponential, and quadratic equations. Here are the examples that we're going to be doing for today. So I'll just jump to the first question. Our first question, we are required to find dy over dx of the following equation, this equation right here. We are required to find dy over dx of this equation here. So the first thing that you need to do is to know the formula, the standard formula that we use. Here is our standard formula that we're gonna be applying here. It's in your formula sheet. In your formula sheet, you'll see an equation like this one here. This is the equation that you're gonna be using here. So if we look at this, we know this is our standard. I'll just write df, standard differential equation. So for this problem, we're gonna just apply this formula. So you're gonna say your dy over dx. The reason why it's dy over dx is because you're differentiating with respect to x. So you're differentiating with respect to x. That's why it's dy for this one, and then dx for this x here. So it's gonna be dy over dx equals to, then you apply this. So you're just gonna say your n, let's write on the side here, n equals to 2, okay, and then n minus 1 equals to 2 minus 1 equals to 1. Okay, so let's just write the equation. It's 3 into our n. What is our n? It's 2, and then x to the power 2 minus 1. So your dy over dx will be equals to 6x, then 2 minus 1, we know it's 1, so it's gonna be, this is equivalent to 6x. So this is your answer for this equation. Okay, and then the next example, it's in fraction form. So if you find equation like this, you have to change it to exponential form. So you're gonna have 3x to the power minus 2. So always when you find equation like this, you have to change it to exponential form so that you can be able to put it in this format. Okay, so the next thing, we apply the same method that we applied. We apply this formula right here, your nx n minus 1. Okay, so we're gonna say dy over dx equals to, we're gonna say 3 into our n, which is minus 2, x to the power minus 2 minus 1. So your dy over dx is gonna be minus 6x to the power of minus 3. So this is your answer. Okay, so we'll just jump to the next example, because this is the basics of differential equation. So this differential equation, it's building up because there is more complex differential equations than this one here. So let me just jump to the third example. So the third example goes like this. I'll just write on the side here, note 4x plus 3 equals to y, where 3 is raised to the power 0. we all know that anything to the power 0 equals to that number. So this 3, this constant, it has got x to the power 0, which is 3. Anything to the power 0, it's 1. So it's gonna be similar to 3 multiplied by 1, which is 3. So we all know that a constant it's raised to the power, it has got a function of x which is raised to the power 0. So I'll just get here, I'll say dy over dx equals to, we're gonna apply that formula, this formula right here, n minus 1. So it's dy over dx equals to, we're gonna start with this one, we're gonna start with 4. So for 4 we have got 4, and then our n is 1, and then x to the power of 1 minus 1. Okay, then for the next one, for this 3, we have 3 to the power x 0. Okay, so we all know that x to the power 0, that our n is 0 here, so we're gonna say multiply by 0, then this 0 minus 1. Okay, so your dy over dx will be 4 multiplied by 1, it's 4, and then x to the power 1 minus 1, you're gonna get 0 here. So anything to the power 0, it's 1. So you're gonna be 4 multiplied by 1. And then for this one, you're gonna say 0 multiplied by everything that is here by 3x to the power 0 minus 1. Obviously you're gonna get 0 for this one. Okay, so therefore your dy over dx equals to 4. So you should know that when you have a constant, a number without a function, when you have a number without a function, you're gonna get a 0. That's why for this 3 here, we got a 0. So let me jump to the next example. So the next example, we're just gonna apply the same formula that we applied as the previous example. So for this one, you're gonna do them one by one. So the first one, you're gonna say dy over dx equals to your 6, and then multiply by your n. Your n is 4. Okay, then x to the power of 4 minus 1. Okay, plus your 3 into your n which is 3, x to the power of 3 minus 1. Okay, plus 4 multiplied by, remember this is raised to the power, this 4x is raised to the power 1, so you're gonna multiply by 1, x to the power of 1 minus 1. Okay, your dy over dx will be 6 multiplied by 4, which is 24. And then you're gonna write your x to the power of 4 minus 1, which is 3, plus 3 multiplied by 3, which is 9, x to the power of 3 minus 1, you're gonna get 2, then plus your 4 multiplied by 1, it's 4, and then this x, as you can see, remember from the previous video, 1 minus 1, you're gonna get a 0, so anything to the power 0, it's 1, so you're gonna get 4 multiplied by 1 here. Okay, so your dy over dx will be 24 x cubed plus 9x squared plus 4. This is your final answer. So this is your final answer. Okay, let's move to the next example. Okay, as you can see, this example it's in a fraction form. So before you differentiate, before you find your dy over dx, you first need to simplify. So to simplify this, we're gonna break here where there's a positive sign, we're gonna break it. So here's what we're gonna do. you're gonna have to simplify it. You're gonna say 6x to the power 4 over x. So you're gonna divide everything by x, plus 3x cubed over x, plus 4x over x. So please note that this is different from this. Let's say your denominator was your numerator. Let's say it was like this, to the power 4 plus 3x cubed. This is not the same. You cannot break this. If you have a question like this, you cannot break it, because your denominator, you cannot break it because of this denominator. So you can't break this. This is wrong. You only break it if your numerator, it has got a positive sign or negative sign, additional sign or subtraction. That's when you can break it. But then if it's like this, you can't break it. Please note that. Okay, let's erase this. Okay, so after breaking this, as you can see, we haven't differentiated yet. So the first thing we need to simplify this. So as you can see, this will be equals to 6 to the power 4. Remember, this is raised to the power 1. So you know from your exponential rules that dividing the powers of the same base, you subtract the exponent. So it's going to be 6x to the power 4 minus 1, and then plus 3x to the power of 3 minus 1, okay, plus 4x to the power of okay, let me erase this. Okay, just write it underneath. So we got, I'll just write it here. You've got x to the power of 4 minus 1 plus 3x cubed minus 1 plus 4x 1 minus 1. Okay, so here we're gonna get 6x to the power of 3 plus 3x to the power of 2 plus 4x to the power of 0. So we all know that anything to the power of 0 is 1. Okay, so here we're gonna get 6 cubed plus 3x squared plus 4. Okay, so after simplifying it, you see it's in a standard form. So after simplifying it, then we can differentiate. We can now differentiate. So as you can see here, we're going to differentiate this. We're going to differentiate this here. So to differentiate this, you're going to apply that formula that we applied for n x to the power n minus 1. So you're going to get 6 into your n, which is 3, x to the power of 3 minus 1 plus 3 multiplied by your n, which is 2, x to the power of 2 minus 1 plus 4. Remember this 4. Remember from the previous video that we said if we have a constant, it's going to be x to the power of 0. So for this one, let me write on the side here. This is the same as x to the 4x to the power of 0. So your n is 0. So you're going to say 4 multiplied by 0, x to the power of 0 minus 1. Okay, so therefore your dy over dx will be 6 multiplied by 3, which is 18, x to the power of 3 minus 1, which is 2, plus 3 multiplied by 2, which is your 6, then 2 minus 1, you're going to get a 1 here, then plus this, which is 0. So therefore your dy over dx will be 18x squared plus 6x. Okay, then this is your final answer. This is your final answer. Okay, so let's jump to the next example. Okay, so as you can see, this example is similar to the previous one. It's similar to the previous one. You see, you've got your sign on your numerator. See, there is a sign. So for this example, you're going to apply the same concept where we break here. We're going to break it. Then before we differentiate, what do? We simplify. So for this one, you have to say 4x. Gonna divide everything by root of x plus, oh sorry, this is not a plus. I don't know what sign is that, but then that's not a plus. Okay, plus 3 over root x. So please note that root x can be written as x to the power of 1 over 2. Okay, so it can be written like this. So for this one, you're gonna get 4x to the power of 1. Okay, remember, dividing the powers of the same base, you subtract the exponent. So it's gonna be 4x to the power of 1 minus 1 over 2, right? Plus 3 multiplied by x to the power of 1 over 2. Okay, it's the same. There's a negative 1 over 2. Okay, let me write it nicely. This is supposed to be negative 1 over 2. Okay, let's do this. It's your x to the power of minus 1 over 2. Okay, so this will be equals to, you have to say 1 minus 1 over 2 for your exponent. You're gonna get 1 over 2. Okay, so here you're gonna get 4x to the power of 1 over 2, which is a 1 minus 1 over 2. You're gonna get 1 over 2, positive 1 over 2. Okay, plus this one remains the same, minus 1 over 2. Okay, and then you can differentiate. After simplifying it, you can differentiate. Dy over dx equals to, okay, we're gonna say 4 multiplied by our n, which is 1 over 2. Okay, x to the power of 1 over 2 minus 1. Okay, plus 3 into minus 1 over 2. Okay, which is your n. X to the power of minus 1 over 2 minus 1. Okay, so your dy over dx will be, so you're gonna say 4 multiplied by 1 over 2, you're gonna get 2. So you're gonna divide 4 by 2, so you're gonna get a 2 here. Okay, then you're gonna say 1 over 2 minus 1. For your exponent, you're gonna get a negative 1 over 2, so it's gonna take you back. Okay, so you're gonna get a negative 1 over 2. Okay, then plus, you're gonna say 3 multiplied by minus half. Okay, you're gonna get, okay, so here you can erase this positive sign, because when you multiply 3 by negative half, you're gonna get negative 3 over 2. Okay, let's erase this sign just to save time. Okay, so when you multiply this, you're gonna get a negative here. So you're gonna get a negative here. So you can write negative 3 over 2 x to the power of, so you're gonna say minus 1 over 2 minus 1. So you're gonna get minus 3 over 2. You're gonna get negative 3 over 2. Okay, so it's up to you. I don't know if it's necessary, to put your answer in a fraction form. But then if you are required to put your answer in a fraction form, then it's easy to put your answer in a fraction form. So if you are required to put your answer in a fraction form, you can say this 2 over root x, okay, minus, it's easier that way, okay, minus 3 over, okay, you've got your 2 multiplied by, remember when you change this, to change this, let me write on the side here, to change this can be written as okay, x, okay, because I'll show you on the side here, because remember your square root is half. So if you've got this cube root of x is the same as x to the power half multiplied by 3, this 3 here, yes, this is exponential rule. Okay, let me erase that, or I should just leave it on the screen. Okay, so you're gonna get this, if you are required to simplify it further or leave it in a fraction form, this is what you do. Okay, so yeah, this is our final answer. So we'll move to the next example. Let's move to the next example. I hope this makes sense, guys. Okay, so the next example, it's almost similar to the previous one. The only difference is that this one is not in a fraction form. So for this example, what you do is to change. Remember what I said from the previous video, that root x is the same as x to the power of 1 over 2. So we're going to change this to, we're going to simplify. Always you simplify before you differentiate. So this is the same as x to the power of 1 over 2. Okay, so then you can find your dy over dx. Dy over dx. You know that your n is 1 over 2. Your n is 1 over 2. So you're going to say 3 multiplied by 1 over 2, which is your n, then multiply by x to the power of 1 over 2 minus 1. So your dy over dx will be 3 over 2 x, then you're going to say 1 over 2 minus 1, then you're going to get a negative half. Okay, you're going to get a negative half. So for this one here, you're going to get a negative half. Okay, so therefore this is your final answer. Okay, so now let's move to the next example. So for this one, before you differentiate, what do? You simplify. So for this one, like I said from the previous video, you have to write it, it has to be in this form, n x to the power n minus 1. So for this one, you have to change it to this form, so to the standard form. Okay, so you're gonna say 3 multiplied by, remember your root x is x to the power minus half. It's minus half, because here it was positive. When it goes up, it's gonna be a negative half. This is exponential rule. Dy over dx. Okay, we're gonna say 3 into your n, which is minus half. Okay, then x to the power of minus 1 over 2 minus 1. Okay, therefore your dy over dx will be minus 3 over 2. And then here you're gonna say minus half minus 1. Okay, minus half minus 1. Then you're gonna get the minus 3 over 2. Okay, you're gonna get your 3 minus 3 over 2 minus 3 over 2 here. There's your exponent. Okay, so from there you're done. You are done with your example. So this was the easiest one, I think. Yeah, because you just needed to change here. Let me just do a recap. You just need to change this to a standard form because it was a positive half here. Then when it goes to this exponential form, it's going to be a negative half. So you just multiply 3 by negative half, which is your n, multiply by x to the power minus 1 over 2 minus 1. There you go. Then you find your answer. Then you find your what? Your answer. Okay, let's move to the next example. Okay, the next example. Okay, let's just simplify everything. Let's just simplify everything. Remember what I said? Before you differentiate, what do? You simplify. Okay, let's simplify here. This 6x to the power half, we're gonna write it as it is because there's nothing to do there. Okay, multiply by 3 into, remember, okay, let's say this bracket here, it's for everything. Okay, remember we're gonna have to change this root x. We're gonna put it in this form, 1 over 2, all multiplied by square. We're gonna square everything, so we're gonna square everything. Okay, so after squaring everything, you're gonna say 6x. Okay, this one you're gonna write it as it is. So let's just solve the 3 root x all squared. Okay, let's solve it. So remember, you're gonna have, let's just remove this squared. You're gonna have 3 to the power of 2, okay, multiply by, remember, let me just show you, this root is gonna be for this, then it's gonna be for this, the square root, because everything is squared here. So you're gonna say 3x squared multiply by x to the power of 1 over 2 multiply by 2, which is your squared. This 2, it's this one here. Okay, that's your exponential rules there. So you're gonna get your 6x half plus 9. Then remember, these two are multiplying, so it's gonna cancel. Okay, you're gonna cancel those two. Gonna cancel. Just remember that. Then you're gonna have your x here, x to the power 1. So you could just write x. So your dy over dx, that's your next step. Remember, after simplifying everything, what do? You simplify. After simplifying everything, what do? You differentiate. Okay, so the next step is to differentiate 1 over 2, which is your n, x to the power of 1 over 2 minus 1, and then plus 9 x to the power of, this one is raised to the power of 1. So you're gonna say 1 minus 1, and then you know your dy over dx is gonna be 6 multiplied by half. A half of 6 is what? It's 3. Am I right? It's 3. Yes, it's 3. Okay, then you're gonna say 1 over 2 minus 1. You're gonna get a negative half. Okay, gonna get a negative half. Am I right? Gonna get a negative half. Okay, let's write negative half here plus oh, I forgot to write times 1 here because your n was 1. Either way, it will be the same. So here you're gonna get a 0. For this one, you're gonna get a 0. And then you're gonna say x to the power of 0. What do you get? It's 1. So here you're gonna get a 9. A 9 alone. 9 alone. Okay. So your dy over dx. Okay, your dy over dx will be let's see. So you have to change this. You can change this to your fraction form. Okay. So you can change that to your fraction form. Okay, so to change that to your fraction form, you're gonna get 3 over root x plus 9. Then yeah, you can leave your answer in this form because there's nothing to do on the 9. So 9, you just leave it as it is. Okay, let's just do a recap. Okay, recap ne. All right, so here you root your 6x to the power half. Okay, then plus open bracket. Okay, 3 multiplied by x to the power 1 over 2 close bracket, all squared. Then you remove the square, you remove the brackets by squaring everything. So it's gonna say, you're gonna say 3 squared multiplied by x to the power 1 over 2 multiplied by 2. Okay, then the 2 is gonna cancel. Okay, it looks fine. Everything looks sharp. Okay, so since everything is sharp, we're gonna move to the next example. Let's do the next example. Okay, the next example. Let's see what's happening here. So let me just write on the side here. You remember that you have to simplify this. Okay, you have to simplify this. So you're gonna have your 4. Okay, then here you're gonna say 4 into, remember what I said, you're gonna write half here for this one. It's a half for this one alone. So you're gonna say multiply by, let me write with the pink one, multiply by 3. Remember from the previous video I told you that you multiply by 3. Okay, plus your 3x to the power of minus 1. Okay, and then here you're gonna get your 4x to the power of 3 over 2. Okay, then you're gonna say plus 3x to the power minus 1. Hey, 1. How? Okay, so after doing this, remember what I said, you apply this formula here, minus 1. Okay, so then after simplifying, what do? You differentiate. Remember that? Yes. Okay, I'm answering myself. Talking to myself. Okay, so you're gonna say 4 into 3 over 2, which is your n, x to the power of 3 over 2 minus 1. Okay, plus 3 multiplied by your n, which is your minus 1, and then say n, which is your minus 1 minus 1. Okay, and then dy over dx is equals to, then you're gonna say 4 multiplied by 3 over 2. You can punch it on your calculator. You'll get a 6. Yes, you'll get a 6. You get a 6 for this one. You're gonna say 4 into 3 over 2. Then you're gonna get, it's gonna be 12 divided by 2, which is 6. Okay, into. Okay, then you're gonna say multiply by x. Then you're gonna say x is raised to the power 3 over 2 minus 1, which is your half. You punch it on your calculator, you'll get a half. Hey, there's not a half. There's not a half. Okay, half, it has to be up there. It's your exponent. Yes, that's your exponent. Okay, so then you move to the next one. You're gonna say plus. How? There's not a plus. Remember. multiply everything by -1. So you could just change the sign here. There's no need for you to write positive into negative. No. Just say negative straight away. 3. Okay. 3, and then you're gonna say x -1. You're gonna get a -2. Okay, gonna get a -2. Therefore your dy over dx will be, could just write 6 root x. Okay, minus 3. How? 3 over x squared. Oh, so you can write it in this form. Okay, I see. Okay, then there is your final answer. Yes, that's your answer. Yes, that's your answer. Okay, let's move to the next example without any waste of time. Hey, problem started. Hey, then the problem started. Okay, so for this one, this is your exponential differential equation. This is your exponential differential equation. Okay, so here's your formula right here. So if you can check on your formula sheet, you'll see this formula. So basically, to solve differential equations, you just need to use your formula sheet. You just go to your formula sheet and then you check. Like for this example, go to your formula sheet and then you check for something like this. Remember, this 3 is your constant. This 3 here, it's your constant. So you just ignore that 3, keep it as a constant. Then you go to your formula sheet. You just apply the method, whatever steps they used on the formula sheet. Just look for something like this: e to the power x alone. Then e to the power x, it will be like this. So let's just solve this first example. There's nothing to simplify here. It's straightforward. Dy over dx. Okay, so dy over dx for this one, we keep 3 as a constant. Then we're going to apply this formula. Then we're going to apply this formula here. We're going to apply this formula. So to apply that formula, let me write it with the, okay, let me write it with the pink for ladies. Okay, let's apply the pink color. Okay, so we're gonna start with this one. So we're gonna say multiply by e to the power of x. It's written as e to the power of x, so you just write as it is. Okay, then multiply by d over dx into, let's see, you're gonna differentiate your x. Okay, no, it's fine. Okay, therefore your answer, your dy over dx, is gonna be 3 e to the power of x into, remember, the derivative of x. On your formula sheet, I know they didn't write this d over dx into x, but it's there. They were supposed to write it. Okay, it's there. So when you differentiate this x, remember, derivative of x, it will be what? So if you differentiate x, let's say it's x to the power of 1, then you're gonna say 1. To solve this, you're gonna say n is 1 minus 1, and then you're gonna get x to the power of 0, then you're gonna get 1. Anything to the power of 0, it's what? It's 1. So that's why they didn't write it on the formula sheet, because it's multiplied by 1. So your dy over dx is gonna be 3e to the power of x. That's your answer. So basically, it's like you didn't do anything. You just write it as it is. How? Yes, it's like that. Yes, it's like that. Okay, let's just erase that. Okay, erase. Okay, so for the next example, for this one here on the right hand side, let's solve it here. Okay, so for this one, you're gonna say, let's see how this one is different. It's raised to the power 2x. How this one is raised to the power of 2x. Okay, but it's not that difficult. just apply your formula. Okay, dy over dx equals to 3, okay, into 3 is your constant, e to the power of 2x. Okay, just write it as it is, following the formula sheet, guys, and then multiply by d over dx. And then for this one, hey, for this one, your f of x is 2x, so you're gonna write 2x here. Hey, yes, you write 2x there. Then dy over dx. Remember this 2x, let me just highlight that, is this one here. And then for this one is this one here. Okay, so if it was 3x, it was e to the power 3x, so you're gonna write 3x here. Okay, I hope that makes sense. Then you're gonna have 3 to the power e 2x. Okay, so you're gonna say a derivative of 2x. What are you gonna get? You're gonna get a 2. You're gonna get a 2. When you differentiate 2x, you're gonna get a 2 for sure. Yes, you're gonna get a 2. So dy over dx equals to 6e to the power of 2x. How? Yes, we are done. Yes, are we done? Yes. So since we are done with this example, we could just move to the next example. Yes. So the next example, it's much complex. But no, it's not. It's not. Okay, so what you need to do here, you just need to write this in exponential form, because here it was positive, it was raised to the power positive x, so here it's going to be negative x. So your dy, after simplifying, what do? You differentiate. So you're going to say 3e to the power minus x into your d over dx multiplied by, remember you take this one here, take that one there, gonna get a negative x. Okay, your dy over dx, it's gonna be 3e, just write it as it is, then multiply by, okay, let's see, when you differentiate this, I can tell you now, when you differentiate x, you're gonna get a negative 1 for this one. You're gonna get a negative 1. You're gonna get a negative 1 for this one. Okay, so therefore your dy over dx will be equals to negative 3e to the power minus x, or you can write it as minus 3 all over e to the power x. How? So this, hey, so what happened is here, let me highlight that. Hey, what's happening now? Let me highlight this. So basically just change the sign. How did that happen? So basically just change the sign from positive to negative. Here it was positive and now it's negative. How is that possible? Hey, it's there. That's your final answer. You got it. That's your final answer. That's meant for you. Okay, so now for this one, for this example right here, you're gonna say y equals to, then what do? You simplify. Remember that? You simplify. Before solving anything, you do? You simplify. Okay, you simplify, guys. Okay, so for this one, you're gonna say 3 into, let's change this. Remember what I said? The square root is like a half. So you're gonna say e to the power of 2x. Okay, multiply by half, which is your square root. Alright, guys. Okay, then your y will be equals to 3e. As you can see, this 2 will cancel. This 2 and this 2 will cancel. So you're gonna be left with x. Okay, so you're gonna be left with x. How is that possible? It's there. There is your answer. Then you're gonna say, after doing this, you say dy over dx equals to, you apply the same rule that you applied there. Gonna write 3e to the power of x into d over dx into a. Gonna take this one here, you're gonna take this one here, then you're gonna write x, you're gonna say x. Alright, your dy over dx will be equals to 3e. This x, when you differentiate x, guys, when you differentiate x, I'm whispering now, when you differentiate x, you're gonna get a 1. So your answer is 3e to the power of x. I hope that makes sense. I hope that makes sense. Okay, so without any waste of time, time, we'll just do the last example, I think. How? But this one looks different. How? This one looks different, guys. Guys, this is a miracle. No, but we can do it. Oh, so for this one, if you go to your formula sheet, you just look for something like this. Just look for something like this, where these two, it's a function, it's a number, can be any number, these two. So you just go to your formula sheet. That 2 is like a in this form. For this formula sheet, your 2 is like a. Okay, so this is the same as, let's write on the side, this is the same as a to the power of 3x. Okay, well, then this one also, it's like a to the power of x squared. How my god, guys, there's a miracle. So you just go to your formula sheet and apply this method here. So you're gonna say, there's nothing to simplify here, you're just gonna say dy over dx, then you just write 2x 3, 2 to the power 3x. Just following the formula sheet, guys. Okay, so when they differentiate this, they are saying you're gonna get, please note that your a is 2. Okay, your a is 2. So they are saying you have to write the question as it is. Okay, so you're gonna write 2 to the power 3x. How? Then ln, just following the formula, ln a, your a is 2, then multiply by d over dx. Remember, what did I say about this? You take this function here. Hey, I hope that will be straight. There you go. So you're just gonna write 3x here, 3x. I think I should just, okay, no, it's fine, it will fit. Okay, so your dy over dx will be equals to 2 to the power 3x. Okay, ln of 2. Then when you differentiate this, 3x, you're gonna get what? A 3. Can I get a 3? Yes, I'll get a 3. So your dy over dx will be equals to, please note that, please, this 3 doesn't multiply with this ln 2. No, I can't do that. I can't do that. You can't. It only multiplies with 2. So you can write it, I think you can leave the answer as it is. So basically you can leave the answer as it is. This is raised to the power of 1. So this is not, it's not like you're multiplying the powers of the same base. If you're multiplying the powers of the same base, you're gonna add the exponent, but then in this case you don't need to multiply the powers of the same base. So you could just leave it as it is. I normally leave it as it is. Don't think they can penalize you for that. Okay. So the next example, which is this one on the right hand side here. So for this one, this one is a bit complex now. Okay, let's erase this. Let's write this nicely because there's no space. This took our space. How? You must share, man. You must share. You must share. Okay, so you're just gonna write 3x. I'm just writing that 2 multiplied by d over dx of 3x. Okay, so now we have space. Voila. Okay, let me just erase this arrow here as well. This arrow. Let's erase this arrow. So this was supposed to come from this. Let's just take it from here. My arrow is not straight, but it's fine. Okay, so for this one, you're gonna say y. You're gonna say dy over dx equals to. So your e. Okay, you're just gonna write it as it is. I don't think you're gonna have enough space here. Okay, let's just do this. Let's just do this. Let's just do this. So let's just do this. So we're gonna say d, because of space, we're gonna say d over dx. From the formula they said you should find d over dx of x squared, which is this one here, d over dx squared. So I'm just simplifying it. I'm just simplifying it separately. So you're gonna find the derivative of this, which is your 2x. Okay, and then you know that your a to the power x, just writing what is in the formula sheet. I'm just writing this. I'm looking for a to the power x, I'm looking for ln a, I'm looking for d over dx. So I'm just finding it separately. So this will be x 2 to the power x squared. Okay, and then ln a will be ln of 2, because your a is 2. So I'm just gonna plug it there. So dy over dx equals to, okay, so I'll start with a to the power x. A to the power x is what? It's 2 to the power x squared. Okay, then ln of a, which is ln of 2, then multiply by d over dx. Okay, d over dx, we got 2x to the power of 1. So look at the difference, guys. Voila, look at the difference. Oh, I forgot to put a bracket. Close the bracket here. Look at the difference. So do you see that there's like, what do they call it, multiplying the powers of the same base? Am I right? Am I right, guys? Because you see this 2, it's raised to the power 1 here. Am I right? Yebo, I'm right. So dy over dx, you can just leave it as it is. I don't think they can penalize you for that. So you take this 2. Okay, let me highlight that. So you take this 2 and this 2. It's like I'm multiplying the powers of the same base. You add the exponent. So you're gonna say 2x squared, this is x squared, and then plus 1. So it's x squared plus 1 multiplied by x ln 2. This is your answer. So you can write it as, it's up to you whether you leave it in this form, or simplify it further. So it's up to you. Okay, guys, I hope this makes sense. So I think that's all for the day. Yes, that's all for the day. Thank you for watching. Thank you for watching, guys. If you have any question, just drop a comment. Thank you, guys.